All right, y'all. Let's talk about degrees and radians. Um, you already kind of know what an angle is, but let's use our specific Algebra 2 language really quick. So officially, an angle is the measure of change from the x-axis to the terminal side. Let me draw that for you. So it'll look like this. And I specifically forgot to mention, sorry, it's the positive x-axis. It's not any x-axis, it's this one. So how much am I rotating from here all the way to there? It's like 225 degrees. And the reason I know that is because the whole thing is 360. Halfway would be 180, and then an eighth of the way to the next one would be like 45 more, so that's 225. We're going to talk a lot more about that, but for right now, let me just remind you that didn't work. That all the way around is 360 degrees, so halfway would be 180, and then a quarter of the way would be 90. So let's just have that down in our notes. And let me introduce you to a radian. A radian is a radius of length around the circle. We kind of talked about this, but I want to show it to you. I'm going to visually show you what this looks like. So let's look. This is the final product, but let's actually watch the whole thing. So I'm going to take a line and draw a circle with it. That red line is a radius. Now, if I take that red line and I wrap it around the outside of the circle, that's a radian. I'm saying that kind of weird. It's a radian. So that's 1 radian. Now I can copy and paste that segment all the way around the circle. So here's 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. There's a little bit extra. Now that little bit at the end is pi. Isn't that cool? So then all the way around is the 2 pi. So there's 6.28 total radians around a circle, but pi is the way that we describe it. Now the reason that it's 2 pi to go all the way around the circle is because the circumference is 2 pi r, so it's 2 pi radians, because radians is the radius, basically. So this is 2 pi, this is pi. We're going to get into a lot more detail about all the little sections of the circle, but for right now, I want you to know that 360 is the same thing as 2 pi, and that 180 is the same thing as pi. And so what we're going to do is we're going to transfer back and forth from radians to degrees, and also we're going to talk about how to draw bigger numbers than 360 on the graph. So let's first of all draw weird amounts of numbers. So I want to draw 500 degrees. It usually says in standard position here, but I wanted to save the space. So if I have just this is an XY graph, nothing weird. I want to draw 500 degrees, and I'm always starting facing the positive X direction, or the, the left or the right. Wow, that's what I get for teaching all day. So what we're going to do is we're going to go around the circle to the left until we get to 360. And then we have to go a little bit more. How much more do we have to go? Well, 500 minus 360 is 140. So we have to go 140 degrees more, which if this is 90 and this is 180, let me just do all of them for you. If this is 90 and this is 180, then I'm going to keep going, right? I'm going to keep going somewhere between 90 and 180. It doesn't have to be perfect, but it'll be probably right around here. So this is my drawing, badly, because I didn't meet it in the middle, of 500 degrees around a circle. Let's do negative 400. So negative just means that I'm going to go to the right instead of the left. I'm still going to start in the same position, but I'm going to start here. I'm going to go around this way. So I'm going to go 360, and then I just have to go 40 more to get to 400. So I'm going to go a little bit more, and that is my, that's negative 400 degrees, and this was 500 degrees. Okay. Let's talk about coterminal angles, because we don't need to go all the way around, right? We could have just gone like bloop and then gotten there. So let's talk about what a coterminal angle is. I might have to use a space higher up to actually do the conversions. So coterminal angles end in the same place. So instead of going to 500, I could have just gone to 140, right? That's what I decided was. So if I want a coterminal angle, what I can do is I can add or subtract 360. Because that's a full circle, so it doesn't really, like it, I don't know, it refreshes itself, right? So if I take 500 and I were to subtract 360, I would get the 140 that is coterminal with 500. I could also do it again if I wanted maybe like a negative one. So I could also do like 140 minus 360 for another coterminal angle. And I don't know what I get. Hold on. Negative 220. So these both are coterminal with 500 degrees. So if I went to 500, I could also just go to 140, or I could go to negative 220. A lot of times when I give you a problem like this, I'm going to ask for two, a positive and a negative, so that would count for this. All right, let's do conversions from radians to degrees. Now here's why this works. Okay, I'm actually going to show you first. So I said that 180 was halfway around the circle, and I said it was the same thing as pi. So 180 equals pi, right? Okay, so radians times 180 over pi is going to get me degrees, and degrees times pi over 180 equals radians. But it's a little bit easier than that, actually. So let's just take 120 degrees. How do I okay, so if I take 120 degrees and I multiply that by pi over 180, what I'm really doing is I'm going to simplify 120 over 180 and then add a pi to the end of it. So that actually equals 2 pi over 3 radians. And then for radians to degrees, or sorry, for degrees to radians, all I have to do is like cancel out the pi and do the rest of it times 180. That's usually what I do. I really ran out of room, so I don't want to like stress you out too much by doing too many problems. But the other way, I would just cross out the pi's and do the little bit of math that's left. So I hope you learned something today. I'm gonna finish color coding this radians right here and maybe do like a box around this. Yeah. So I hope you learned something today. If not, email me, come to office hours, ask me in class. You know the drill. And I'll see you next time. Okay, bye.